Good evening, everyone.
Good evening, everyone.
Good evening, ma'am.
Okay.
Good evening, ma'am.
So in today's session, we are going to see the summary of week 3.
Okay, ma'am.
Is my screen visible?
Yes, ma'am.
Yep.
Yes, ma'am.
So the week 3 contains the structure of the C program, okay, the keywords, variables, data types, operators, and how to evaluate the expressions, and how to read input and output in C programming. Okay, so these are the concepts covered in week 3. So every C program will start with the preprocessor directives. So the preprocess. So suppose if you are writing some code, say for example, so if you are writing a code, so every C says just this is the code to print the hello world, just a message on the screen. So if you observe, the first statement is hash include stdio.h. This we call it a hash include, is called a preprocessor directive. So what is mean by a preprocessor directive is every program will have a input and output. So for input and output, we are using a printf and scanf functions in C language. So those function definition, those are predefined functions. We are not defining it. Okay, so the definitions of those input output header file. Okay, so your processor has to bring that stdio.h file to your program, so that whenever you use a scanf or printf, it will refer the definition of that in the stdio.h. Okay, so before file, and that it will include in your program. It will insert at the beginning of your program. Okay, so that is preprocessor directive. So any preprocessor directive will start with a hash symbol. Okay, you are defining some word hash define. So this is also a preprocessor directive. So for defining the constants, we use hash define. For including the header files into your program, we use hash include. Okay. So in your program, you can write it like this: hash include stdio.h hash define pi 3.14. So this is a symbolic constant. We are defining its value as 3.14159. So wherever you use, say, pi, it will substitute this value. Wherever we use pi in our program, so it will substitute with this value. Okay. So you cannot modify this value later. Because it is a constant, you cannot able to modify it in the program. Just you can substitute. Wherever you use pi, it will substitute that value. You can use any here you can use any constant name. Okay, these constants are called symbolic constant. So for defining the symbolic constant, we use a preprocessor directive called hash define. So generally, in every C program, so in the combination of so many functions. So one of that function is a main function. So your program execution will always starts and end with the main function. So inside the main function, you can also call some sub-functions to perform a particular task. Okay. So suppose you want to use one variable in all the functions that we have defined. Okay. So suppose here I have written a function called A. I have written a function called A. And somewhere again, somewhere in some other statements or inside the A function, I have called another function called B. This is A function. Inside the A function, I have called another function B. And the definition of that function I have written here. Same. So in all these functions, suppose if I use some common variable. Suppose I have used some common variable. So such a variables, the variables which you want to access in all the functions throughout the entire program, those variables are to be declared outside of all those functions. Outside of all those functions, that we call it as a global declaration. Here I can say int x. Say for example, I can declare a variable, a global variable, say int x here. So this is called, because this in x is defined, declared outside the definition of all the functions. So this is my main function. This is a function A. This is function B. So outside of all the functions, I have defined a variable called x. So that we call it as a global variable, which can be accessed inside all these functions without passing it as a parameter. Okay, it will be from the place of declaration till the end of the program, it can be accessible. So that is called a global variable. Okay, so global declaration include variables and even functions also you can declare them globally so that it can be accessible in all the sub functions as well as in the main function. Okay, throughout the, so whichever component you want to access throughout the program, you have to declare that component as a global component. Okay, so it should be defined outside of all the functions. If you declare something inside the function, so that will be accessible only within that function. Once you come out of that function, it cannot be accessible. Okay, so whereas global variables are accessed throughout your program in all the functions. Okay, Say, for example, here I have declared some global variable, global var, so whose value is 10. So it is an integer variable. Okay, so it is defined outside of all the functions. So you can treat this as a global variable. Okay, say, and I can also define a function. Say, add is a function which is taking two parameters, a and b, and returning an integer value. So addition of these two is returned by this function. So this is a global function which is declared outside the main. Okay, so this is a global variable. This is a global function. So if global declaration is an optional part, you can, if you want, you can include, otherwise need not. And the next, write the function sub-function definitions. After that, you can write all your sub-function definitions, sub-functions that you have used in your program. Those definitions you can write it next. After global declaration, you can write the declaration of those functions. Okay. And then after that, we will write the main function. Okay. So add is a, so this is a function declaration, a global declaration we did. Add is a function which will add two integers a and b and return an integer value. So declaration will always terminate with a semicolon, whereas the definition doesn't have a semicolon in the first line. Okay. So this is the definition. Definition means what it should do. That in the definition, the first line is always a declaration, except the semicolon. And then inside this, what you are doing, you are returning the sum of a and b. So we are passing two parameters a and b to this function, and it is returning the sum of those two values. Okay. So when you add two integers, the return value is also integer. So the return data type is int, we have specified here. So when you are declaring a function, it should be like this: the return data type space function name. Within the bracket, you need to specify the parameters required. So as to this int a, and I am naming those two integers as a and b. So int a comma int b, these are the parameters. Name of the function I am using is add. This can be any user defined name. So you can say sum, or you can say add, or it can be any user defined name. As per the user convenience, you can use any name. And this is the return type. So so every C function will return some value, single value. Every C function will return a single value. So what is the data type of that single value returned by that function? So that you need function to add two integers. So when you add two integers, what will be the result type? It will also be an integer. So the return type is an integer. Add is the name of the function, and parameters to this function are a and b. So inside that, what we are doing, we are returning the sum of those two. So this is a sub function. Add is a sub function. So it's a function. Even you can write the sub function, or that functionality you can even write it inside the main also. Okay. So this sub function definitions are also optional. So, but this main function is a compulsory function. Always your execution will start and end with the main function. So we write the main function declaration like this: return type space function name, and main is not taking any parameter. So open and close parenthesis, immediately we will place it. Main is the name of the function. So because the function is returning an
And your voice is
integer
breaking in between.
Yeah, lagging,
at
man.
the end, last
Same issue here.
statement that you need to write it
Madam,
here is a return 0.
madam,
So why we'll write this is,
madam, your voice is breaking.
when
madam.
you are executing the main function,
Madam,
there might
Ma'am,
madam,
be some errors. You may occur or encounter with some that can be terminated. There are hundreds and thousands of reasons why the program will fail. So, for example, thinking again, 1 minute. Hello?
Yes, ma'am.
yes, ma'am.
Wait. All of you switch off your mic, ma'am. So is my screen visible?
Yes, ma'am.
Yeah. Tell me if you have any voice problem again. Okay.
Okay, ma'am.
So we need to define a subfunctions if they are. So after that, we need to define a main function. So in the main function, say while executing the main function, why we write this return 0 is, say when you are executing your main function, maybe due to some problem, some error, your program may terminate abnormally. Say for example, suppose you have written a statement like this: C is equal to A by B. So suppose you have written a statement, C is equal to A by B. Somewhere A, B are defined, and we have written before that we have written some statement B equal to B minus 3, something, some calculations we made. So because of that, the B value has become 0 by the time it execute this statement. Suppose the B value is 0. So in that case, what happened? It cannot divide with 0. You cannot, so it cannot find out. So when you divide with 0, you will get an infinite value. So that infinite value, how to represent, the computer doesn't know. So that's why it will raise an error. Okay, raise an error. So your program here, it will terminate abnormally without continuing. It will terminate. It won't execute your program. Okay, so like that, there are thousands of reasons for which your program may terminate abnormally. So whenever it is terminating abnormally, it will raise one error condition. Okay, it will return some error value. So every error will have a code, some code, non-zero value, error code. So based on that, your system will know what type of error has occurred, whether it is a division by 0 error, or whether it is input is not given, or undefined variable it found. So some errors may be. So based on what type of code it has written, based on that, it will evaluate what type of error it is. Okay, so all the error codes are non-zero values. Whereas if your program has executed successfully, all the statements of your program has been executed successfully, so at the end we will return 0. So if this function returns 0, that indicate that your program has terminated normally. That means successfully it has completed the program. That is the indication. So that's why we write return 0 at the end. So if none of the above statement causes any problem, so then it will able to execute this statement. So when your program executes, when your compiler executes this statement, that indicates that your program has successfully completed. Okay, so that is the meaning of return 0. So next, so initially you will have a processor directives. You need to include processor directives, then global declaration section. So global declaration section is an optional. If you want, you can define them, and even defining a subfunctions is also an optional. If you want, you can define a subfunction, but defining the main function is compulsory. Okay. And you can also write comments. You can also write comments wherever it is required. So the comments are two types. The C program will accept two types of comments: single line comment and multi-line comment. Suppose you don't want to execute this code. Just this is written only for understanding purpose, if you think. So you can comment that line using a double slash. So from the place where we have written this double slash, from there to the till the end of that line, it will make it as a comment. So when it is commented, your compiler will not execute that code. So that is called a single line comment. So single line comment will start with double slash. Okay. Whereas a multi-line, suppose you want to remove multiple lines. You don't want to execute. So you have written a code and you are testing. Your mind has thought that there are two logics that you can write to solve this problem. So you have written both the logics. Say, for example, you have written both the logics. So in that case, what happened here? You want to execute or test only the first logic, and in that case you can comment the second logic. So okay, like this. So multiple lines if you want to comment, so it will be slash star, and you have to put those lines between slash star and star slash. Okay, so this is called a multi-line comment. All the lines, all these lines will be commented. It will not be executed by your compiler. Okay, your processor will not execute those. Okay, so you can use wherever. Generally, we include the comments to increase the readability of the program. So generally, initially also we'll write the comment to indicate who is the author of this program, for what purpose this program is written, and who generated on which date this code was written. So you can include, based on your requirement, you can include those information in your program using commenting lines. Okay, so you can use either a single line comment or multi-line comment. If you are using a single line comment, we use double slash. If you are using a multi-line comment, so in the beginning you put a slash star, at the end of the comment you put a star slash. So this is a multi-line comment. So this is the complete idea of what we'll have in the structure of the C program. First, we will have a preprocessor directive. After that, there will be a global declaration section. Global declaration section. After that, you will have the definition of the subfunctions. After that, we will have the definition of the main function. Main function. Okay. Even the subfunction definitions, you can write either above the main or below the main. The subfunction definitions, you can write them either above the main function or below the main function. If you write above the main function, you need not declare them. You need not write the declaration of those functions. Suppose if you are writing the definition of the subfunctions after the main function, then the declaration is must before the main. So by seeing this declaration, your main program will knows that there is one function with the name add. To call that, I need to pass two integer parameters. So that will be an information to your main program. Suppose if you didn't give this declaration and you have written the definition of that function after the main, so sometimes you may get an error. So if your function is returning an integer, you won't get the error. But if it is returning something else other than integer, so in that case, you will get an error. Okay, so it is always good. It is always preferred or good to maintain the declaration of the function before the main. Okay, always be a habit of declaring all the subfunctions before the main function. Or instead of writing a declaration, you can write the definition here itself. Okay. So this is the main structure of your C program. So now what we will write, in which order we need to follow inside the main, not only main, any subfunction. Okay, inside the subfunction, which order we need to follow. Okay, so suppose this is my main function. Suppose this is my main function. Always inside the main function, first you do the declarations. So you might have used some local variables, the variables which will work only within this function. So those local declaration variables, local variables are to be declared first. So first you write the necessary declarations. After that, always you write read your input. if required. Suppose if it is a subfunction, your input you may get through parameters. So if you are not getting the required input through parameters, you have to read the input. The next order after declarations, the next step is you have to read the required input. So after that, you write the processing statements. You write the processing statements to process your input and calculate your output. Okay, so those steps are called processing statements. After that, so when you process your input, you will get the output. So now display your output. Next step is display your output. So this is the order that you need to follow while writing the, in general, if it is a main. Okay, so first you write the declaration of all your variables. After that, read your input. After that, write the processing statements and then display your output. So every C program will have input, process and output. Okay, you have to read the input from the keyboard. After that, you process your input to get the output. Once you got your output, you display it on the screen, output device. Okay, so display the output, read the input. So this is the order that you need to. So you cannot write processing statements first. After that, read the input. So to process your data, first we need input. So this is the order that you need to follow while writing any C program. Okay, so inside the function, you will have all these steps. Suppose if it is a subfunction, not the main function. If it is a subfunction, generally, when you have a subfunction, there are so many types of subfunctions that we will declare clearly in the 5th week or somewhere. But just for an idea, I am saying the subfunction, generally we write it to that subfunction, we will pass the input from the main. From the main, we will pass the input. Your subfunction will perform the processing step and it will return the output to the main. Okay, to the calling function. So suppose if it is my main, it is my main function. So in this, suppose I have called a subfunction A. I have called a subfunction A. Okay. So how this subfunction? So while calling A, so or add, say my subfunction name is say add. So I said add two values, say 4, 5. Okay. So what this add function will do is, so it will be defined like this. Add, so int A, comma, int B. Int A, comma, int B. So it is taking 2 parameters. These are my inputs. So those inputs are passed from the main. A value is 4, B value is 5. Okay. And inside this, it will calculate, it will write only the processing step. Okay. So it will declare the variable C and it will write C is equal to, it will calculate C is equal to A plus B. So C is my result and it will return that result. Okay. So this function, what it is doing, so the input to this function is passed as a parameter from the calling function and it will write only the processing steps here and the result it will return back to the main function. The result it will return back to the calling place. So inside the subfunction, it is only doing the processing step. So declare local variable declarations and processing only it will do. So it will return the output and it will take the input as the parameter. So in general, the subfunction functionality is that only processing will write inside the function. So input will be passed to the function output will be returned from the function. Okay, so that's why we return the output to the calling place, we write a statement called return. Okay, so in general it will be like this, but you can write a function without parameter or without return value, or with parameter with return value, or with input without output, or without input with output. So like there are different categories you can write, that we will see it in the coming weeks. Okay, so that is the structure of the C program. So generally you'll have a total 6 sections, I think. Global declarations section, and then before that you will have a preprocessor directive section, preprocessor directives, and then next section is global declaration. Next section is subfunctions. After that we'll have a main function. Okay, so inside the main function you need to do declaration, first declarations. After that you need to read the input. After that you need to write a processing statements, and then return the output, sorry, display the output. Okay, so this is the simple structure of any C program. Okay, so when you are learning a particular language, you need to learn first we will learn alphabets, or in the computer sense we call that as a character set. Okay, so the character set of C language will include alphabets like small a to z, capital A to Z, digits 0 to 9, and special symbols like comma, semicolon, dot, okay, hyphen, underscore. So like that you'll have some special characters also. Okay, so these are the character sets supported by your C language. So once we learn the alphabets, we will form the words. Okay, so the words are called tokens. The words that we call them as tokens. So there are different types of tokens. So one of that is keywords. So keywords are the words which are having some special meaning in the language. Those words are keywords. We call them as keywords. So there are 34 keywords supported by your C language. These are those 32 keywords, 34 keywords. So actually previously we used to have only 32. Now in the newer versions 2 more get added. Now it becomes 34. So these are the 34 keywords. So you need not remember them. While learning the language, you will encounter all these keywords. Okay, while learning the language, you will encounter all these keywords. So these are the these are the reserved words. We say them reserved words. You cannot use these names as your variable name or a function name. Okay, so you cannot name a variable called do. You cannot write a variable. You cannot write a function whose name is enum. Okay, so like that, these are the reserved words. You cannot use them as a variable names or function names in your program. Okay, so in this generally what we will have in these keywords, we will have your data types. So how we floating point data or a double or a character. So like that, int, float, double, char, all those are the keywords. See here, int, float, okay, double, char, all your basic data types are keywords. Anyhow, even the control statements like if, while, do while, for, all those are the keywords. Or you will have some storage classes like auto, extern, static, all those are the keywords. And even you can define some variable as a constant. So const is a word, we use it to define the constant. So that is a keyword. So like that, you can, to come out of the loops or to break the continuation of your flow, we can use some statements like break and continue. So those two are the keywords. So like that, we will encounter all these keywords while learning the language. You need not remember it now. Okay, just you need to know there are some keywords or the reserved words in C language. Those names you cannot use them as a variable names. They will have a specific meaning in the language. That is about keywords. Okay. So next token is variables. So one of the tokens is keywords. Okay. Next type of token is a variables. So as the name itself indicates, its value can vary. Variable means its value can vary. So variable is nothing but the name of a memory location. Variable is nothing but it is the name given to the memory location. So everything in the computer we store in a memory, whichever you want to store. Suppose I want to store a value 10. So how we will store that is, so in the computer you will have one memory, and each memory location is of 1 byte if you think. So every memory location will have some address. So suppose at a 2000 address, I am going to store 10. Okay. So like that, so 1 byte, each byte of your memory will have an address. Suppose if we take 1 KB of memory, kilobyte. So that means 1000 addresses you will have. 1 KB of memory means 1000 addresses will have. Suppose if I take GB or TB, so lakhs and crores of addresses you need to remember. So that is very difficult for us to remember all those addresses. So that's why what we will do is, whenever you want to store your data, okay, so in which memory location you are storing, to that memory location we will give a name. Say this 2000 location, I am calling it as A. So that in that memory location I am storing a value 10. So how here what we will do is, it is easy for us to remember it with the names. So there is one variable called name A, whose name is A, and in the A value is 10. So it for as a human beings, it is very easy for us to remember with the name. Okay. So but inside how it will be stored is, so some memory location it will allocate. To that memory location it will name it as A. In that memory location it will store this value 10. So that means variable is nothing but the name given to your memory location where your data is storing. Have you understood what is mean by variable?
Yes, ma'am.
Okay. So for our easiness, we will name them with some X, Y, Z or A, B, C, D, something like that. Okay. But computer doesn't know what is A, B, C, X, Y, Z. It will know only the memory location. Okay. So for our easiness, we are using names to the memory locations. So variable is nothing but the name given to the memory location. So while giving the names, we need to follow certain rules to name your variables. So here we are declaring one variable, say integer variable a. I am saying a. So which names we can use it here? So to give the name to your variable, that variable is also called an identifier. So variables, constants, all these are called identifiers. So I am discussing here the rules for writing identifier names. Okay, so it can be a function name or a variable name or a constant name. So it will be applicable to all. So what are the rules that you need to follow is, first rule is it should be formed using alphabets, digits, and an underscore symbol. So it can be formed using a combination of alphabets, digits, and an underscore. Other than this, you should not have anything on the variable name. So your variable name can contain only alphabets, okay, or alphabets and digits, and an underscore. But other than that, you should not contain anything. Okay, so that is the first rule. So the valid rules for the first rule is, say for example, like my variable name can be ABC. Okay, or my variable name can be A12, or my variable name can be total amount, TOT underscore amount. So like generally we will use the variable names according to the scenario of the problem that we are solving. Okay, say for example, I want to calculate the distance traveled by an object. Say for example, I want to calculate the distance traveled by an object. So what is the formula? Distance is equal
Speed into time.
Speed by time.
to speed into time. Is it? So distance, how much distance it has traveled, the object is the speed of that object multiplied by the time it has traveled. So I can use speed. Lagging ma voice. Hello ma.
Yes, ma'am. Sometime your voice is
Yes,
lagging.
ma'am. Your voice is breaking, ma.
Clear.
Okay, let me connect with the mobile also. I will use the mobile audio. Wait, I think might be a signal. This is a peak time, no? Maybe signal problem. Wait a minute. Hello.
Yes, ma'am.
Wait. Hello. Now is it audible, ma?
Yes, ma'am.
Yes,
Yes,
ma'am.
much better.
Yes, ma'am. Ma'am.
So a variable, suppose you want to calculate the distance traveled by an object. So the formula is distance is equal to speed into time. Okay. So I can represent the distance with a variable name distance or d. I can represent the speed with a variable name s or speed. I can represent the time with a variable name t or time. Okay. So I can use a different names as a user, which will be convenient to me. That name I can use it. So, but in general, even I can say instead of DST, I can say A equal to B into C. Even that will work. But how it will be suggested is use the variable names according to the scenario of the problem that you are solving. Okay. So here I am calculating a distance. So it will be meaningful if I use a d equal to s into t or distance is equal to speed into time. But there is no meaning of using a equal to b into c. Okay. So suppose if you are writing some competitive exam or you are going for an interview. So you are asked to write a program to calculate the distance. So you require 3 variables. So you have used the variables names as ABC and you have calculated everything. It has executed and you got the answer. But there is another student who has also written the same program by using a notation like this. Distance is equal to speed into time. So he will be selected, you will be rejected. Because both have written the code correctly and executing for every input, it is giving the correct answer, everything is okay. But always it should be readable. Your program must be readable. So after reading that, what is happening there, that should be understood by the user who is seeing that program, should be understood by the user. So this will give the more understanding or the clarity what you are doing, whereas this is not giving that clarity. So always it is preferred to use the same names according to the scenario of the problem that you are solving. Okay. Say for example, you are calculating the total bill, suppose total bill. So you can use the name of that variable as total bill, but you cannot separate them with space. You cannot. So because the first rule is it should be formed using alphabets, digits and an underscore. Only with these. So there is no space in this. So you cannot use a total space amount. You cannot use it like this. Okay. So if you want to combine two different words at the same scenario to represent a variable, so you can separate them using an underscore symbol. If you want, you can separate them using an underscore symbol. Okay. So is it clear, ma? Is it clarity in my voice?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Yes, ma'am. Yes.
So this is the total, you can use underscore symbol. So first rule is that alphabet can be formed using alphabets, digits and an underscore. Okay. Whereas the second rule is it must always start with an alphabet or an underscore. It cannot start with a digit. Okay. Variable name should not start with a digit. Starting letter must be alphabet. Okay, it can be, starting letter can be alphabet or an underscore. It cannot be digit. So according to this rule, is it okay if I write like this? Is it a valid variable name?
No, ma'am.
No,
No.
ma'am.
Whereas this is a valid variable name, amount to 2. It is a valid variable name. So
Yes, ma'am.
the starting letter must be alphabet or an underscore. It cannot be this. Or even you can write it like this, underscore amount. This is also valid. Okay. So that is the what the second rule is saying. The third rule is it cannot be a keyword. Keyword. So you cannot use, already I specified, you cannot use keywords as the variable names. Say for example, can I have my variable name as int because it is formed using alphabets only? Is it a valid variable name?
No, ma'am.
No,
It's a
because
keyword.
it is a keyword in C language. Okay, so that is another rule. Okay, and most probably in older version there is a restriction on length of the variable also, length of the variable name also, like how many characters it can contain. Maximum, like if it is a previously in the initial you will have only 8-bit systems. After that we have a 16-bit processors. After that we have 32. Nowadays you have a 64 or 128-bit processors also. So that bit means 8-bit, maximum 8 characters. In the older versions, your variable name must not exceed 8 characters. Suppose if I say total amount 1, total amount 2. Suppose I have 2 variables with one, first variable name is total underscore amount 1. The second variable name is total underscore amount 2. So in this almost I have how many characters? 12, more than 12. Okay. So, but in the older versions, it can able to recognize only the first 8 characters. Up to here, there should be some distinction between this variable and this variable. So both the variables up to 8 characters are same. So it cannot able to identify these 2 variables as a different one. So in older versions, nowadays, you can have a variable up to 128 also, but always it is preferred not to exceed your variable name more than 32 characters. Okay, that is only a even not, don't write even up to 32, 16 only use. Okay, so it should be simple and precise, and it should give you the meaning, the scenario according to, it should give you the correct meaning for your scenario of the problem. So in such a way, you select the problem. Don't use lengthy variable names. Okay, but even though there is no restriction on the length nowadays, but you don't try to don't form much lengthy variable names. Okay. So these are the some of the rules that you need to follow while writing the variable names. Not only variable names, constant names, identifier names. Okay. So so that is about variables. And now we'll see how to declare the variables. So while writing the program, according to our scenario, we will write some names to your variables. Okay. So those I said while writing the function, the first statements that you need to write is the declaration of your variables in your program. To represent your input, we use the variables. To represent your output, we use some variables. For intermediate calculations, we use some variables. So all those variables used for input, output, and temporary calculations are to be declared first. Declared. So your C program should know what type of data it carries. So whether it is it contains a integer value, or whether it contains a real number, float value, or whether it contains a string, characters. So it should know. You have to inform to your compiler that what type of data it is carrying. Okay. So for that, we need to know what are the basic data types supported by your C language. So there are 4 basic data types supported by C language: int, float, double, and char. So as of now, I am saying int is a whole number, float is a real number, something like this, 34.25 something, float a real number. Int is a whole number, say for example 20. Double is also a real number. The difference is float and double both are used to represent the real number only. In the computer, you will have the ranges. In the last class, we have discussed. Suppose if it is, we are giving a memory of 8 bytes, you can, how much big number you can represent. If it is a 16 bits, how much big number you can represent. If it is a 32 bit, how much big number you can represent. So based on, so float is a 4 bytes, whereas double is 8 bytes size. So it can represent somewhat larger numbers, whereas it can represent a numbers up to some range only. Okay. So both are used. So if you want to use a larger value in your program, then that variable you have to numerical value, which is somewhat larger. In that case, we use double. Otherwise, we use float on real numbers. Okay. Whereas char means character. Suppose you want to write your name, string. Your name is a set of character. Anything which is written, any character in your character set. That means alphabets, digits, or special symbols. All those are the character set. Any character in your character set which is enclosed in single quote is considered as a character. Okay. Whereas anything which is enclosed in double quotes is considered as a string. Anything which is enclosed in double quotes is considered as a string. Anything which is enclosed in single quote is considered as a character. Okay. But there is no data type called string. We represent the string as a character array. So we'll write a declaration of a string like this. Suppose you want to write your name. So it is a character. Say name is my variable name. Variable which represents the name of the person. And how many characters you want to use for representing your name, that size you need to mention in the square bracket. So this is called a group of characters. Okay. So here you can store a maximum of 20 characters in this variable. So then this name will become a string. String is nothing but set of characters. But there is no data type called string. So if you want to use a string in your C program, you have to declare it like this. Character, this we call it as array. Array is nothing but a group of values it will contain. So your name is a string. It can carry up to maximum of 20 characters. You can specify even the other length also. Suppose if you say 50, it can able to store up to 50 characters. Maximum, the length which you are specifying there is nothing but a maximum length. Okay. So these are the basic data types in your C language. So if you want to declare your variable, you have to use the syntax data type space variable name. This followed by semicolon. So data type space, at least one space, after that variable name. Say suppose I want to say A is an integer. So first you need to specify the data type. To represent an integer, the data type is int. space A is the name of the variable. After that, put a semicolon. So that indicate your processor that there is one memory location. It will allocate when you declare this. What happened inside the computer is when it sees this, it will allocate one memory location of the required size. Integer in general, it based on your processor, whether if it is a 16-bit processor, it will allocate 2 bytes. If it is a 32-bit or more, it will allocate 4 bytes of memory. So it will allocate 4 bytes of memory. To that memory, it will name it as A. To that memory, it will name it as A. So that is the importance of declaration. Why we need to write a declaration is, this is to inform your processor that I want a memory location of this size where I am going to store this value, integer value. That is an indication. So by seeing this, it will allocate the required memory to you, and that memory is named as A. Okay, that is the meaning of your declaration. So float, suppose if I say F, so float will also occupy 4 bytes. So it will allocate 4 bytes of memory, and that memory is named as F. Suppose if I declare some double variable, double D. There are 2 variables I want to declare. Suppose double variables I want to declare 2. So D1 and D2, both are double variables. You can write different variables of same type separated by comma, and at the end you need to put a semicolon. Okay. Suppose I want to declare 3 integer variables. You can write them A, comma, B, comma, C. All the 3 names you can write it in a single statement itself. Okay. So A, B, C are integer variables. F is a float variable. D1, D2 are the double variables. So this is the declaration. Okay. So variable declaration, it will be data type. At least one space should be there. After data type, at least one space. You can even use more than one space. After that, you should have a variable name. At the end, you should have a semicolon declaration. Okay. Say, for example, you want to represent the age of a person. So age, in general, age, in the real world, age will be, we will specify them in integer value. Say 10 years, 15 years, 16 years, 25 years, like that we will say. We won't say 24.3 years like that, age. Okay, in general, age is represented as an integer. So age, I have declared age variable like this. Okay, so always when you are using a variable, what type of data it should carry, you should think of in the real world how that variable will be. Suppose if you are specifying the time or other, so in general, suppose if you are using a distance calculation only. So suppose what is the data type of distance? Generally we say 15.5 kilometers or 12.3 kilometers, something like we'll use a real number. So distance is a float variable. Okay, whereas speed can also be, say, float variable. Time can also be, say, like always we can't say the time in hours. So we say 2 hours 30 minutes. So in that case, what we'll write 2.5. Okay, so time is also a real value. So like that, when you are declaring your variables, you have to compare those quantities or the resources with the real world, and you assume the possibility of the data type and then declare them. Okay. So next is a variable initialization. So initialization is the starting value. Sometimes what we do is, we want, suppose I have a marks in 5 subjects. Say for example, I have a marks in 5 subjects. Subject 1 mark, subject 2 marks, subject 3 marks. So like that, I have a marks in 5 subjects in 5 variables. Now I want to calculate what are the total marks of me. Okay. So in that case, what I will do is, I will declare a variable called total. So here I have specifically saying 5 variables. You can write the formula of total as total equal to S1 plus S2 plus etc. up to S5. But sometimes I don't know. In one semester, I might have 5 subjects. In another semester, I might have 3 subjects. In another semester, I might have some 10 subjects like that. So in that case, I don't know. So I need to take that. N is the number of subjects I have. So what I will do is, I will put a loop which will execute for 10 times, and I will add one by one subject to the total. So total equal to total plus ith subject. Yes, I'm saying yes suffix I. Okay. I value will vary from 1 to 10. So first time when I value is 1, it will add subject 1 marks. When I value is 2, it will add subject 2 marks. So like that, this statement will be repeated how many subjects I have. So in that case, what I'm doing here, total equal to total plus. That means initially, if I have a total with some value, then only it can add to that you are adding the subject marks. So whenever you have a variable in both the sides of the equal to, the same variable, if you have both the sides of the equal to, that variable must and should have the initial value. So initially, what we'll take is total equal to 0. Initially, before adding any of the subjects, my total marks is 0. After adding subject 1, it will contain S1 value. So after adding S1 plus S2, it will contain both the subjects. So like that. So initially, whenever you are using a statement like this, initially in both the sides, if you are using the same variable name, that variable must have some initial value. So that initial value, you can assign it in the declaration itself, or you can write it later also. Okay. So while declaring the variable, so here I am declaring a total variable equal to some value. If you give, that will be taken as the initial value of that variable. Okay. In the declaration itself, you can write that. Or if you didn't write in the declaration, you can later in the statements, you can write it like this using equal to. Okay. So that is how to declare or initialize variable initialization. I means data type, variable name equal to initial value. Put a semicolon. This is the assigning the initial value in the declaration itself. Okay.
Hello, ma'am.
Yes, ma'am.
How do we know that when we had to comma and when we had to give a parenthesis, like when we write a program of adding two numbers, then we write percentage, sum, and comma and parenthesis
That
in the
we will
line.
come. That we will
How do we
encounter.
know that when we had to give what thing?
Yeah. So variable declaration must be terminated with a semicolon. So there are rules where, so when you are writing a function, parameters must be in parenthesis. When you are declaring multiple variables are when you reading multiple variable values, those multiple values must be separated by comma. We will specify the syntax. So there you are. See here, when you are declaring, if you are declaring a single variable, I said simply you can write, say int S1, put a semicolon.
Yes.
Okay. Suppose if you want to declare two variables, S1 is one variable and S2 is another variable, both are of type int. So then you need to separate this variable from this variable by using comma.
Okay.
Multiple declarations when you have, or multiple readings if you have, or multiple displays you have, in that case, that multiple values must be separated by comma. Okay. And every C statement will end with a semicolon. Every C statement
when we
will end
write
with
the functions like a printf function and scanf function, then I don't know when we like, ma'am, yesterday I tried to solve the graded assignment in which first question is we had to write the formula a square b square is equals to under root 4ac.
Okay. So we will discuss
That
that scanf and printf also. Now I will discuss in the class, because the last topic is input output reading. So
Yeah,
there
okay.
I will tell you where you need to use comma, where you need to use something. Okay.
Yes.
So here I have declared an integer variable count and it initialized its value to 0. Okay. So after that, in this I have already discussed what are the naming rules that we need to give to the identifiers. So it should include letters, digits, and an underscores. Okay, it must start with a letter or an underscore, second rule. And another name I forgot. So variable names are case sensitive. That means suppose if I have used one variable called amount. So I have declared amount, a variable called amount. All are in smaller case letter. Okay. Suppose I write another variable A as capital, amount only, but in the amount I have written A as a capital A and the empty is a lowercase letters. So your computer will treat these two, even though it looks like the same for us, amount and amount. It looks like the same for us, but computer will distinguish the uppercase letters from lowercase letters. So it will treat this as a one variable. This is a different variable. Okay, this is a different variable. So it is case sensitive. If you in the declaration, if you use capital letter, you use capital letter throughout the program. If you use a smaller case letter, you have to use smaller case letters only in the throughout the program. In the declaration, how you have used your variable name with capital and smaller case letters, in the same manner you have to refer it in all the places where you are referring it. You remember that. Okay, you cannot say. Most of the mistakes the starting students will do is here they will declare a small AMT. Somewhere they will write capital AMT. Somewhere some smaller letters, some capital letters they will use. So computer cannot understand that. So it will treat the small amount AMT is a different amount with the first letter as capital is a different, and all the capital letters is a different variable. Okay, like it is a case sensitive language. You have to use the same name with the same case in all the places. In the declaration, how you have used it, in the same manner, you have to use it in all the places. Okay, so you cannot you may be called in your home, you may be called as a Buji or some nickname. In your college, your friends may be called with some nickname, and your staff may be called with your roll number. So you might be having a n number of names. You as a human, you will understand all those are yours only, but computer cannot understand that. So it is a case sensitive language. You have to use the same naming convention in all the places. Okay, so that is also another rule while forming the variable names. Okay, so reserved words cannot be the keywords. So these are the naming rules. When you are naming your variable or when you are using a function name, you have to follow these rules while writing the name. Any user defined name. While writing any user defined name, it has to follow these rules. Most of the mistakes done by the students when they are writing a variable name is they will use a space in between. Say total amount, suppose they want to represent. They will write total as one word. After that, they will use a space and amount as one word. But as for your assumption, total amount is a single variable, but computer cannot understand that. Okay, so that is a common mistake done. So spaces cannot be used in variable names. Remember that. So next is the data types that we have already discussed. So 4 data types, basic data types. Int, to represent an integer, we use int. So int will accept both the negative values, positive values, and 0. Okay, so most of the systems based on your processor, if it is a 16-bit processor, it will take 2 bytes. It is more than 62 bits, it will take 4 bytes. 32-bit or 16-bit, 64-bit, it will take 4 bytes of memory. Okay, floating point variable is used to represent the real numbers. The size of it is 4 bytes. Same way, double is also double precision, we say. Double is also used to represent the real numbers only, but somewhat larger values it will represent. It will take 8 bytes of memory. As the memory is increasing, you can represent somewhat larger numbers. That is the meaning. Okay. So character, anything which is enclosed in a single quote is called a character. See here how the character variable is initialized. Single quote. You have to put it in a single quote. Okay. And Boolean values. Boolean values means true or false values, on or off, true or false. To represent that, we use a Boolean values. Actually, there is no special data type called bool in older versions, whereas the recent versions is having this, but it will not work in our editors. So always to represent a Boolean value, we will use them. Suppose we want to say that this is true to the computer. If you want to say this value is true to the computer, any non-zero value, if you give, that is taken as a true by your computer. Okay. 0 is taken as false. Okay. Any non-zero value, whether it is negative or positive, any non-zero value is taken as true. 0 is taken as false. Whereas when it is returning the answer to us in the Boolean form, to say that this is false, it will return 0. To say that it is true, it will return 1. Okay. Boolean values. Always true is indicated using 1, false is indicated using 0. But when we are giving to the computer, it will take any non-zero value as true, 0 is false. Okay. So there is another data type called void. Void means nothing. You don't know what to say. Nothing is there. If you want to say nothing is there, in that case, we use void. Void is a data type, one of the data type. So it represents nothing. Okay. Suppose if you, while declaring a function, if you say here void, that means it is not returning anything. This function, generally any C function will return a single value. We need to write the return type of that value. So if it is not returning anything, so in that case we write void here. Void means nothing. Nothing is written. Okay, void is also one of the data types. Even after that, we will encounter, we can define a new data types using typedef keyword. Okay, so that we will see it in the later classes. Some you can define a new data types using typedef, structured data types and enum, enumerated data types that you can create, user defined data types. So not only these basic data types, you can use some qualifiers and quantifiers with this. So the int can be a normal integer, or it can be a long integer, or a short integer, or signed integer, or an unsigned integer. Okay, so you can write it like simply int, or you can say long int, or you can say short int, you can say signed integer, or you can say unsigned integer. Okay, so what is the meaning of this is, by default your data type will be equivalent to either a long or short. If you say int, in 16-bit processors it is equivalent to short. Long means it will take the double the memory. Ante suppose if your integer is taking 2 bytes of memory in original, so if you declare a long int, it will take 4 bytes, double of it. Suppose if your integer is equivalent to long, because your processor is a 16-bit processor, so integer will take 4 bytes. So in that case, short means half of it. If you declare a short integer, it will take 2 bytes of memory only. Okay. So by default, your integer, your data type will be equivalent to either long or short. If it is equivalent to long, short means half of it. If it is equivalent to short, long means double of it. Double of that memory it will take. So for example, we will take integer in our normal system, integer is 4 bytes. Then long integer will also take 4 bytes only. Whereas a short int will take only 2 bytes, the size. Okay. So in the same way, float, for float also you can use long float or long float. So by default, float is equivalent to short float only. Long float means double. It is nothing but a double. So float is always equivalent to short float only. Okay. So I think the power is gone. Network might be disconnected. You may not see my screen, but I'm talking from the mobile. You will be able to listen to me. Okay, wait a minute. I'll connect the mobile network to the laptop. Mobile connection. Is it visible, ma?
Yes, ma'am.
Visible? Now it's visible, ma'am.
Okay. So by default, int is a 4 bytes. So long int means, so int might be equal to either long or short. So if it is equivalent to long, the short means half of it. If it is equivalent to short, long means double of it. So same way, you can apply this long and short to the float also. If you take a float is always equivalent to the short float, which takes 4 bytes. So long float means double. Long float means double of the memory. That means it will take 8 bytes. Long float will take 8 bytes of data. So 8 bytes will be taken by double. So long float is nothing but double data type. Okay. So long double, suppose you can use, so double is equivalent to short double. Long double means we will expect 16 bytes because double is 8 bytes. Long double means we will expect 16 bytes, but remember that long double will take maximum size of any variable is a 10 bytes only. Okay. So long double, the size of long double is 10 bytes. Remember that. Only for that case it is exception. So you cannot say long or short to the character variable, character data type. Okay. So generally long and short are used to the numerical variables only. So int, float and double are numerical variables. You can use them long, short. So based on your requirement, suppose you want to represent somewhat bigger integer value. So you declare this as a long int. Even you can say long int. That will increase the size. Okay. So next, this is signed and unsigned qualifiers, where we use is by default. So if your variable need to accept both positive values as well as negative values. If you want to represent, your variable should represent both negative and positive values, then it is called a signed integer. Okay, by default, any data type is a signed data type only. Int, float or double, all are signed data types only. If you say unsigned, so it will represent only positive values. It won't represent negative values. It will only represent positive values. Unsigned means 0 to only positive side. So because of that, suppose if we take 1 byte of memory, you can represent a values in the range minus 128 to 127. Because in the positive side, 1 will be decreased because 0 is always considered in the positive side. So minus 128 to 127 you can represent with 1 byte of memory. Okay, so as you are increasing the number of bytes, that range will vary. Okay, so if you say unsigned, so in that case it will represent 0 to this, the memory locations used to represent this 128 values will also be added to the right side, so you can represent up to 255. 1 byte means you can unsigned 1 byte can represent the values from 0 to 255 because there is no negative. So sign bit can also be used for data, representing the data. In the last class I have discussed. So among the 8 bits, 1 bit is reserved for sign, whether to represent it is a positive number or negative number. We use that bit. Only the remaining 7 bits only can carry the data. But in case of unsigned value, that signed bit is not required because it represents only positive values. So signed bit is not required. So that signed bit will also be used for representing the data so that the range will increase. Okay, so the range will be increased. So that those are the qualifiers that you can use. Short, long, signed, unsigned, those you can use. So if you want to declare something like a constant, like if you declare your variables, initially you gave a value of 10, later you can change its value to 20 or 50 or something. Okay, variable. Suppose if you declare something like a constant, while declaring, say I have declared a double variable pi with some initial value, and in before that I mentioned this const. That means you are making this variable as a constant variable. That means its value you cannot change it after first initialization. Wherever you refer, it will substitute this value. If you are trying to change its value, it will give an error. So you want to make something as a constant, you cannot change it, it cannot be modified, then you can use this keyword for the declaration. Okay. The next token. So in between, now what are the different tokens that we have discussed? One is keyword, another is a variable. Okay. The next token is operators. You have operators. So what are the different operators we have in a C language? So actually there are 3 types of operators supported in C language. First one is unary operator. Unary operators. The second one is the binary operators. Third one is a ternary operator. Okay, as the name itself, unary means one. Operators which works on single operand are called unary operators. Say for example, say you familiarly you know the arithmetic operators plus. So how we'll write? So a plus b. So that means this plus is an operator, and a and b are called the operands. A and B are called the operands, and plus is an operator. So unary means here you will have only one operand. Here for this plus, how many operands are there? 2 operands. So binary operators will work on 2 operands, whereas unary operators will work on single operand. Single operand. So the operators which works on single operand are called unary operators. So the unary operators you have are, the familiar ones are plus plus, minus minus, increment and decrement operators. We call them as, okay, complement, not, logical not. We have a function called size of operator, and unary plus, unary minus. So this unary plus and unary minus indicates sign, whether it is a positive. Say suppose if you want to write a number -5. So this is unary minus, not arithmetic minus. Okay. So that indicate, unary minus indicate that it is a negative number, whereas a unary plus indicate that this is a positive value, negative value or positive value. To represent that, we use unary plus and minus. So these are the some of the unary operators. Unary operators. So these are the unary plus and minus indicate the sign, whereas the size of will indicate. So I am saying that integer will take 4 bytes, sometimes 2 bytes. So in your system in which you are executing, you want to know how many bytes are occupied by your integer, you can use a size of operator. So if you display the size of int, so it will return how many bytes occupied by your integer. Say 2, if it is taking 2 bytes, it will return 2. If it is taking 4 bytes, it will return 4. Like that, you can find the size of any variable. Okay. So size of function will help you. It will return the number of bytes occupied by your variable in the memory, by your operand. That operand can be data type or variable or a constant, whatever it may be. Whereas a not means a logical not. It is, suppose if you have a true value, not of true will give you the false. Not of false will give you the true. Okay. Say for example, if I have a equal to 10, I have assigned a equal to 10. B equal to, I say not a. If I said b equal to not a, then what is the b value? Can you tell me? A value is 10 and I have said b equal to not a. Then what will be the b value? How it will calculate? See here, I said already, any non-zero value is treated as true. Any non-zero value is treated as true in your program. So a is a 10. 10 means a non-zero value. So that means a value is true. Negation of true is false. So system has to return the value of b to us. When it need to return the b value, it will be returned false. False means it will return 0. So b value will be 0 in this case. Okay. Suppose if I say a is 0, so then what is the b value?
1.
So 0 means false. A value is false. Negation of a will be true. True means it will return 1. B value will be 1. Okay. So to represent a false, it will return 0. To represent the true, it will return 1. But while considering any non-zero value is taken as true, 0 is taken as false.
False.
Okay. So like that. So this not is for logical operator not. True means it will return false. False means it will return true. And this tilde symbol is used for one's complement. So it is a what we say bitwise operator. Tilde is a bitwise operator. Suppose if I have a something like this, a equal to 5. Okay. So first tilde will work on bitwise operator. Bitwise operator means you need to represent your variable in binary form. Binary form. So what is a binary equivalent of 5? 101. So if you think that it is taking 1 byte of number.
0101.
Okay. So this is your A. Suppose I am representing my number using 1 byte of memory. So 1 byte means 8 bits. So these are the 8 bits. Okay, A value. So one's complement of A means A equal to one's zeros will become 1, ones will become 0.
Zero.
So 1, 1, 1, 1, 1, 0, 1, 0, like that. Okay. One's complement operator. Bitwise one's complement operator. Tilde means. Okay. So it is acting on single operand. So that's why it is called unary. Okay. And it is very, very important. This increment and decrement operators, you see. So
And
the increment
pre-increment means-
operator will increase the operand by 1 unit. Okay. Say for example, if I say A equal to 5, A equal to 5. So A, I can write plus plus A, or so B equal to, if I say B equal to plus plus A, or I can also write B equal to A plus
A
plus.
plus plus.
So
Is
this
it
is called a
same?
pre-increment. Pre-increment. This is called pre-increment. Whereas this is called post-increment. Post-increment. So both, whether it is a pre-increment or post-increment, both will increase the value of the operand by 1. That means A will become 6. So the meaning of this is plus plus A means the meaning of this is A equal to A plus 1. It will increment the value of A by 1. So, but where we will find the difference between pre-increment and post-increment is, suppose if you are using this value in an expression. So here I am using this value in an expression. Okay. So in that case, how it will be substituted is, pre-increment means first value of A is increased. That increased value is substituted in the equation. Okay. First value of A is increased. That increased value is substituted in the equation. Whereas in case of post increment, first it will substitute the current value of A in the equation. After that, A gets incremented. So in both the cases, A will become 6. But what is the B value? It depends on whether the B is assigned with the value of A before increment or after increment. So in this case, first it will increase and then assign. So B will become 6 in this case. But in this case, B will be 5 only. First it will assign the value of A to B. After that, A will increase. So A will become 6. But before incrementing that, only it will assign that value to A. So B will be 5 in this case. Okay. Have you understood? You need to understand this concept clearly. Pre-increment means first it will increase the operand. That increased value is substituted in the expression. Post-increment means first it will substitute the value of that operand in the expression. Then it will increment. In both the cases, that operand will be incremented by 1. Okay. Say for example, I have taken A equal to 10, B equal to 5. So I have written C equal to A plus 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 minus minus B. So what are the ABC values after executing this statement I have asked you? What are the ABC values after executing all these three statements one after another? So what happens? A value is 10. Here I have incremented the A value. So A will become definitely 11. Whether it is a post increment or pre-increment, whatever it may be, I have increased the A value. So A will be 11. And initially B value is 5. I have decremented the B. So definitely B value will be, decrement means it will decrease the value of variable by 1. So B value will be 4. 4. Okay. then what will be the C value? That
15.
we need to evaluate here. So this is a post increment. Post increment means first A value will be substituted here. What is the A value? 10. After that, it will become 11. So 10, but in the equation, it will substitute 10 only. So 10 plus, and this is a pre-decrement. This is a pre-decrement. That means first it will be decremented and that decreased value will be substituted. So B will become 4 and it will substitute that 4 here. Pre means after affecting the value, that affected value will be substituted. Post means original value substituted, after that the value gets affected. That is the difference. So you will get your C value as
14.
In general, how we'll think? So because this is 11 and this is 4, it will be 15. But that is not the truth. So you have to see whether it is a post increment or
A
pre-increment or a decrement. That is the difference between post and, so this is how they will work. Increment, pre-increment, post-increment, pre-decrement, post-decrement. So next category of, so all these are unary operators. So the single operand, they all will work on single operand. See here, plus plus is applied on A. Here minus minus is applied on B. So all these are worked on single operand. That's why those operators are called unary operators. Next, we'll see the binary. Binary means you will have a two operands. Say something like A plus B. So plus is a binary operator. It acts on two operands. Operands are A and B. Okay. So operators which acts on two operands are called binary operators. There are different categories of binary operators. Let me list out them clearly. So first category is arithmetic operators. Arithmetic operators. There are arithmetic operators are plus is used for addition, minus for subtraction, star for multiplication, slash for division, and modulus for remainder after division. These are the 5 arithmetic operators supported in C language. Okay. I think I need not explain how to do the addition, how to do the subtraction and all. Just I'll give one example how you will perform the division. See here. See, suppose if I say 10 by 3. So what is the value of this? 10 by 3. So you may expect, or 10 by 5, or sorry, 10 by 2. So let 3 only. Let it be 3 only. So you will expect that as 3.33333, something like that. Okay. So you will expect that as 3 point. Wait a minute. So it will expect it as 3.333 something like that. Okay. But how your computer will evaluate this expression is, first it will check the data types of the operands. So when you see this is an integer and this is also an integer. So when it is performing an operation between two integers, the final result will also be an integer. Or you can say, for example, I have written an equation A equal to C equal to A into B or something like this. Here, think that A is an integer, B is a float. Suppose A is an integer, B is a float, you think. So when you are multiplying, so among this, integer is a smaller data type, float is a bigger data type, double is somewhat bigger data type than float. Okay, character is the smallest data type. So among the data types, the smallest one is char because it takes only 1 byte. The next smallest is an integer because it may take 2 or 4. The next smallest is float because it takes 4 bytes. The next one is double. This is the preference. Okay. So double is the largest data type, whereas a char or int are smaller than the other type. So when it is evaluating an expression, so first it will check the result. Always the result will be the larger data type among the existing data types of your expression. So here I said A is an integer, B is a float. So A is an integer, so A is an integer, B is a float, I said. So among these operands, whichever is the larger data type?
Float.
Float. So the result will always be the larger data type among the operands. And the C value will be float only. The C value is float. The result is float. Suppose if these two are integers, A and B are integers, then definitely the result will also be an integer, because the largest data type among the operands is an integer. So your result will always be integer. So here also the same case, 10 is an integer, 3 is an integer. So the division will also result an integer value only. That means it will give 3, not 3.333. The result. So you remember that. When you are performing a division between two integers, your result will also be an integer. If any one of the either numerator or denominator is a float, then your result will be float. Suppose if I write 10 by 3.0 specific, so 3.0 is a real number. So in that case, you will get this result. Okay. By default, it will display up to 6 decimal places. After decimal point, it will display 6 different values, up to 6 digits accuracy. Okay. So always you remember this when you are performing the division operation. When you are performing a division between two integers, your result will also be an integer only. Okay. If either your numerator or denominator is a float, then your result will be float. Otherwise, it will be integer only. Okay. Remember that. So, and modulus is a reminder after division. It will work only on integers. Okay. So, if I say 10 mod 3, that means when you divide the 10 by 3, so the remainder left out is 1. Remainder after division. Okay. So it will work only on integers. So whereas these 4 operators will work on any numerical data type. And you need to remember that concept when you are using a division. If both of, like when you are evaluating your expression, what will be the data type of your result is, among your evaluations, whichever is the larger data type, that will be the result, your result data type. Remember that. Okay. So these are the arithmetic operators. So I need not explain. Next category of binary operators is relational. The second category of binary operators are relational operators. So relational means less than, greater than, less than or equal to, greater than or equal to. So, less than, greater than, less than or equal to, greater than or equal to. These are the relational operators. So you can say, suppose for example, A equal to 10, B equal to 5. I said C is equal to A greater than B. What is the C value? I need not say the meaning of greater than.
Untrue,
Okay?
true.
True. So 10, A value is 10, 10 greater than 5 is true. True means what is the value written by your system? 1. So C value will be 1. Okay. Always the relational operators will return a Boolean value. Remember that. the relational operators, when you use them, they will return true or false. That means they will return either 1 or 0. Relational. So this is less than. If it is less than, it will return true. Otherwise, it will return false. So if it is greater than, it will return true. Otherwise, false. Less than or equal to means when both values are same. So if I say A greater than B, false. 5 greater than 5 is false. Whereas if I use 5 greater than or equal to 5, in that case, it will return true. Equal value also it will check. Okay, that is it. I think I need not discuss what is less than, what is greater than, what is less than or equal to, what is greater than.
Yes, ma'am.
Okay, but how they will work is like this. Always they will result a Boolean value. Okay, so those are the relational operators. Whereas there are another category of operators, we call them as equality operators. Some books, it will also be represented like a relational operator only. So equality, we call them as equality operator. Equality operators. So there are two equality operators, double equal to and not equal to. Okay, so generally these operators are used for comparing two different values. Say for example, A equal to 10, B equal to 5 if I have. So I have written A, C is equal to A double equal to B. Okay, suppose I have written like this, A double equal to B. So that means this double equal to operator, it will check whether both A and B are having the same value or not. If they are having the same value, it will return true. If they are having a different value, it will return false. So here A and B are having a different values. So this statement will return false. False means C will become 0. Okay. Whereas not equal to is opposite of equal to. If both are different, it will return true. If both are same, it will return false. Opposite of double equal to is not equal to. Okay. So double equal to not equal to will compare whether both the operands are having same value or not. Double equal to will return true if both are same. It will return false if both are different. So not equal to is just opposite of double equal to. So in this case, what will be the C value? C value will be false. False means 0. Okay. So instead of that, if I use here not equal to. So both are different. Here also both are different. So it will return true. In that case, C value will be 1. Okay. So those are equality operators. So somewhere here both are represented like relational operators only. So relational and equality operators both will return a Boolean result. Boolean result, that is true or false. Next category of operators are logical operators. Logical operators. So logical operators, you have 3 logical operators and or not. Already we have discussed about not. Not is a unary operator. So it won't come under binary operator, but it is a logical operator. Okay. So the binary logical operators are only 2, and or. So generally logical operators are used to combine more than one condition. More than one condition. If I say, for example, you are eligible to write or to attend this program, you must have an intermediate qualification, and you should secure more than 60% in the entrance exam. Suppose I said, to attend this particular program, you should have the eligibility as one of the condition is you should have an intermediate degree. The second condition I am saying is you should score at least more than 60 in the entrance exam. So the first condition and second condition. Both must be true to become the whole thing is, this program is eligible. Whole thing to be true and means both the conditions must be true. To say that those two conditions are to be combined with and. If I combine something with and, that means both the left hand side condition as well as the right hand side condition must be true to become the whole expression to be true. Okay. Say for example, if I say C equal to A greater than B and A greater than C. Wait. So some variable is max equal to, I said A greater than B and A greater than C. So I have given ABC values as A equal to 10, B equal to 20, C equal to 5. Suppose I gave the values of ABC is like this. Now, what will be the max value? Yes. First, it will check this condition. A greater than B. Is it true or false?
False.
False. See here, when this is false, and condition means both must be true to become this to be true. If any one of the condition fails, the result of this is false only. So if the first condition itself fails, it won't execute the second condition at all. The result it will return as false. So max value will be 0. Okay. Suppose if I gave the B value as 7, then what happens? A greater than B is true. So when it is true, then it will evaluate the second expression. A greater than C, that is also true because 10 greater than 5. So this is true as well as this is true. So and condition, so when both the conditions are true, it will return a true value. So max will be true, so its value will be 1. Okay. So this will, and condition, what it will specify is, to get the true result for this, both the conditions must be true. Then only it will return the true to the result. Otherwise, it will return false to the result. Okay, if any one of the condition fails, so suppose if this is true, this is false also, false only. If this is false, false only. When both are false also, false only. Only when both are true, this will be true. Okay. So whereas R is any one of the condition must be true. So I can say either you have to pass intermediate or you need to secure greater than 60 in the entrance. Any one condition is enough to eligible to attend this course, if I say. Then in that case, we combine those two conditions with R, either this or that. So if I combine two conditions with R, so if this is true, then it won't check this value because this is a true, only one condition is enough for the output to be true. Here itself we can decide. So if this condition is false, then it will check this condition. If this is true, it will return true. If both conditions fails, then only it will return false. Otherwise, it will return true. R means any one of the condition must be true to get the true result. Okay. And condition means both the conditions must be true to get the true result. That is it. Okay. So those are the logical operators. Next is assignment operators. Next category of operators is assignment operators. I think another 15 to 20 minutes it will take now. So assignment operators means equal to. The most common assignment operator that we use is the equal to assign, to initialize some value to the variable, we use equal to. Whereas there are some shorthand notations that we can use while assigning a value. Suppose if I have a statement like this, A equal to A plus 3. I have a statement like this. So when you have the same operand on both sides of equal to, then you can, instead of writing 2 times this, you can write this statement simply like this. You can write this as A plus equal to 3. Sorry. A plus equal to 3. You can write this statement as like this. So instead of writing A 2 times, we can use a shorthand notation. This is called shorthand notation. So if you say operator before this equal to, that means this variable is there in both sides of equal to, the meaning of that. So instead of writing the same variable on both sides of equal to, you can use a shorthand notation. So the shorthand notation for assignment, you can use it for all your arithmetic operators and also for logical operators. Like, see, for all the arithmetic operators, you can use plus equal to, minus equal to, star. Like even and equal logical operators also, you can use the shorthand notation. Okay. So for all the operators, you can use a shorthand notation. Wherever you find that the same variable appears on both left and right hand side of equal to, instead of writing it 2 times, you can use a shorthand notation. That will also give you the same meaning. Okay. So this is equivalent to saying num equal to num plus 3. This is equivalent to saying num equal to num minus 2. Okay. So we have already discussed about increment and decrement, pre-increment, pre-decrement, post-increment and all. Okay. So these are the, actually there are some more binary operators called shift operators and left shift, right shift, bitwise operators. Okay. So we'll discuss them in the end. Okay. So anyhow, here they were given up to only this, but I'll discuss them also. Okay. Bitwise operators. So now suppose in an expression, so how to simplify and how to write an expression is nothing but a combination of variables, operators, constants combined. You can form an expression. Okay. Say for example, I can say C equal to A plus 3. Here, so semicolon. If you put a semicolon, it will become a statement. Okay. If you write without semicolon, that will become an expression. So this is one expression. So one constant is an expression. A single variable is an expression. A constants or variables combined with your operators is called an expression. So all those are expressions only. So expression will contain, it can be a combination of operators, variables, constants, like that. Okay. Here we have, in this expression, we have two variables, A and C, and one constant, 3, two operators, equal to and plus. Okay. So this is an expression. So how to evaluate an expression? Suppose, for example, I have taken an expression, arithmetic expression, 4 into 2 plus 5 by 2 minus 7. So something I gave. So this is my expression. This is my expression. I want to simplify this. What is the value of it? So your computer, how internally it will perform is, it will perform one by one operation only. So because this is having so many operations, one multiplication, one addition, one division, one subtraction, like that. So for that, it will follow which operation need to be performed first. For that, we use the operator precedence and associativity rules. Operator precedence and associativity rules. Okay. So operator precedence means among all the operators, unary operators have the highest precedence. This is the order. Okay. Might be you have studied the BODMAS rule in your school. First, you need to evaluate which is there in the brackets. After that, multiplication, division, multiplication. After that, addition and subtraction. So like that, you might have studied. So here also almost the same. So first precedence is for something which is there in the parenthesis. This is having the highest. So first we need to evaluate what is there in the parenthesis. And next precedence is for unary operators. So first, among the existing operators, if you have a unary operators, that is to be evaluated first. Next. Okay. After that, we need to evaluate multiplication and division. Both are having same precedence. Multiplication, division and modulo operators have the same precedence. And after that, we need to perform the addition and subtraction. After that, we need to perform the relational operations. After that, we need to perform equality. After that, we need to perform and. After that, we need to perform or. At the end, you need to perform the assignment operator. So the least precedence is for comma. Okay. So this is the precedence order. So suppose, here I have taken in my expression, I have taken only arithmetic operators. So among the arithmetic operators, plus division and star and modulus have highest precedence. Plus and minus have the next precedence among the arithmetic operators. So that means first I need to evaluate star and slash. These two are having the same precedence. Now, if you encounter same precedence operators in an expression, which one is to be performed first? Whether I need to do the multiplication first or division first? To decide that, we use the associativity rules. Okay, we have seen the precedence rules. Precedence rules means first parenthesis, after that unary operators, after that arithmetic star, slash and modulo, after that arithmetic plus minus, after that. So these are the precedence. Suppose the same precedence operators appear in your expression, then we need to go for the associativity rules. So the associativity rule is whether I need to evaluate from left to right in the expression or from right to left. So operators will have two types of associativities, either left to right or right to left. Only unary operators and assignment operators are having the associativity right to left. All other operators have the associativity from left to right. Okay. All the other are having left to right. Only unary and assignment operators have the associativity right to left. So here we have used only arithmetic operators. All the arithmetic operators associativity is left to right. That means in the expression, whichever operator that comes on the left hand side is to be evaluated first, after that right hand side. So among the star and the slash, which appeared first? Star. So first you need to evaluate the star. So this will become after evaluation. So 4 into 2, first you do it. For 8, it will become 8 plus 5 by 2 minus 7. So among, now you have 3 operators. Among the slash is having highest precedence. Now you do that. So 8 plus 5 by 2. What is the 5 by 2 value? Because 5 is an integer. 2 is also an integer. So 5 by 2 will be 2 only, not 2.5. Okay. So 2 minus 7. So now we have two operators, plus and minus. Both have the same precedence. So associativity of plus and minus is left to right. So in the left hand side, we have the plus. First you perform the plus. So 8 plus 2 is 10 minus 7. So 10 minus 7 is 3. So the answer, the evaluation of this expression will be 3. So you have to evaluate according to the rules of precedence, operator precedence and associativity rules. Okay. So that is about operators and how to form an expression and how to simplify the expressions. Okay. Now I think already I have discussed the input output in C in the last class. In the first class I have discussed. So for reading the input, we use a scanf function. For displaying the output, we use a printf function. Okay. Standard input function is a scanf. Standard output function is printf. So both will have the same syntax except some differences. Scanf, the syntax of scanf is scanf. Here we need to provide a control string. Control string. The control string must be enclosed in quotes. After that, put a comma and symbol that indicate address of a variable, and then variable name, and then put a semicolon. So this is the syntax of scanf statement. Okay, here you need to provide the variable name. Which variable value you want to read from the keyboard, that name you need to mention here. Okay, variable name. So this is the syntax. So here, as per the syntax, what is mean by a control string is, so control string is something, a percentage symbol followed by one character. That character is based on the type of this variable you are reading. It depends on the type of the variable you are reading. Suppose you are reading an integer variable, then this must be D. Generally, we use decimal integers only. So decimal integer, to read the decimal integer, we use control string as D. So percentage D is the control string to read an integer variable. Okay. Percentage F is a variable control string we use to read a float variable. And percentage LF, long, double means long float. Long float is nothing but double. So to represent long, we use L. LF, long float, is used. Percentage LF is used to read a double variable. Percentage C is a character, so is used to read a character variable. Percentage S, we use it to read a string. Okay, so these are the control characters that we use. These control characters, we need to use them based on the type of this variable you are reading. Okay, suppose let me declare some variables. So int a comma b, a b are integer variables. Float f comma f1, f comma f1 are float variables. Double D is a double variable. Char ch is a character variable. And name is a string variable. So how to declare a string variable? How to declare a string variable? Char, name is the name of the variable, and you need to specify how many characters you want to store in that size. Okay, so this is a name is a string. So I have declared these variables. A, B are integers, F1 are floats, D is a double, CH is a character variable, name is a string variable. Now suppose I want to read a value from the keyboard. A value from the keyboard. So how to write the statement? Scanf. Here, because I want to read the A value, so my variable name is A. Okay, my variable name and variable name is A. So what is the data type of A? It is integer. So the control string we need to mention here is %d. %d. And I can read more than one variable also. I can read more than one variable also. So when you are reading a more than one variable, those variables must be, you can read it in a two different statements. You can write scanf and A, and then you can write another scanf and B. But you can read in a single statement also. So here you separate, you are reading multiple values. Those multiple values must be separated by comma here. And here, how many variables you are reading, those many control strings you need to provide here. So first variable is an integer, you use %d. Second variable is also an integer, so you use another %d. This %d is for A and this %d is for B. You need not give any space. So you write the control string without any spaces or commas, anything. Okay, you write continuously. Or another chance is, by default, variables are separated using a space in your output device. So you can use a single space. Don't use double or triple spaces. You can use either a single space between your control strings or don't use anything. If you have a confusion, don't use any spaces or special characters between the control strings. Okay. So this is how to read more than one variables of same type. Suppose now I want to read A value and F value. A value and F value. So A value and second variable I want to read is F. So and A and F. And the control string for A, because A is an integer, control string is %d. F is a float. The control string for float is %f. Okay, in the order, in which order you are reading the variable, in the same order you specify the control strings. First variable is an integer, so first control string is %d. Second variable you are reading is a F, so second control. So variables must be separated by comma, but control strings should not be separated by anything. You write one after another. Even don't put a space over here also. Before the quotes and after the quotes, don't give any spaces. Okay, that will also cause a problem. Or the another way I said is, here you can use a single space. Remember that. If you have the confusion, don't use anything. Write one after another immediately. Suppose I want to, so reading a character variable, reading the double variable, all these are same. But reading a string is something different. Okay. Suppose you want to read your name. How we'll write is scanf. Anyhow, we'll encounter the strings separately. But time being, I am saying how to read a string. So while reading the string, don't use ampersand symbol, this and symbol. And symbol don't use while reading the strings. Because when you are reading your basic data type variables, you must and should have and operator. Whereas a string is not a basic data type. Name is a string variable. String is not a basic data type. So don't use and symbol here. Why we will encounter later when we are discussing the arrays. Okay. So remember this. While reading all the basic data types, your variable must be preceded by and symbol. Whereas while reading the strings, it should not precede by and symbol. Okay. That is how to read the input. Whereas for displaying the output, we use a printf statement. Printf. So same syntax. Control string. Quotation close, comma, you don't have the and symbol, ampersand symbol, just simply variable name you write. To display, we use this. So, control string is the same meaning in case of, if you are displaying an integer value, use %d. If you are displaying a float value, %f. If you are displaying a double value, percentage LF. If you are displaying a character, percentage C, same control strings we use. But the difference between, now see the differences between scanf statement and a printf statement is, in the scanf statement, you should have only the control string, doesn't have anything else. No messages, nothing should be there in scanf. Whereas, while in the printf statement, along with your control string, you can have some default message. Suppose you are displaying the sum of two numbers. You can say sum is equal to that result variable you can write. Okay. So you can put a message also along with your control string. You can put a message also. Okay. So that is one difference. Another difference is here you will have and symbol, ampersand symbol. Here you won't have the ampersand symbol. Those are the only two differences between printf and scanf. The keyword is different. Here we use the keyword scanf. Here we use the keyword printf. That's the function names are different. Suppose now I'll write a small program. Okay, complete program. How your C program is written. So first statement that we need to write. So I am writing a program to display your arithmetic operations. That means I will read two values. I will find the sum, difference, product, quotient, and a remainder for those two operators. So first thing that every program will have a input output. So you include stdio.h. This is the first statement. So hash include stdio.h. Next one is, we don't want any global variables here. So I'm skipping the global variable section. So I am writing a main function. Main is a compulsory function. So int main, and here I am writing the definition of the main. So inside the main, first thing that we need to do is a declaration. So I am taking two integer variables. Let them be AB. AB are my inputs. And the result I am storing. S is the sum. D is the difference. P is the product. Q is the coefficient. R is the remainder. So let us think that AB are my inputs. My outputs are sum. Sum I am representing using S. Difference using D. P is a product. Q is a quotient. R is the remainder. So I am using these variables. So I have declared them. Now the next step after declaration, next step is reading the input. What is the input here? AB are the input. So you need to know the AB values to calculate the sum, difference and all. Okay. So two numbers you need read. Scanf. Okay. You are reading the values of A, comma B. Okay. And what is A? Data type of A is an integer. So percentage D. B is also an integer. So we'll write two control strings, percentage D, percentage D. So that will read the AB values. Every statement in C end with the semicolon. So now I will calculate the result. Third step, declaration is over. Reading the input is over. Now what we need to do? We need to calculate processing steps we need to write. So in the processing, we need to calculate the sum. So sum is represented using S. So S is equal to A plus B. We'll write the formula to sum. So D, difference, equal to A minus B. Okay, P equal to A into B, product. And quotient equal to division. So A by B. And then remainder equal to A mod B. Remainder after dividing A by B. So these are, so I have calculated processing steps I have written. Now I want to display the result. So the next step is display your output. So printf, I can write, I have 5 result variables here. One is yes, sum, D is the difference. You can write 5 different printf statements, or in a single printf statement also you can display all the 5. Okay, so here I am writing printf. So what I am printing, for that I am writing sum is equal to, here you write %d, and where, in which variable I have the sum? Variable s. S contains the sum. So sum equal to, wherever you find a control string, in that place it will substitute this value, this variable value. Okay, same way you can write a 5 different printf statements. Control V, the difference equal to %d, where I have the difference in d. So like that, product equal to, like that you can print all the values. But in a single statement also I can write that. So here you can write. So after displaying the sum, you go to the next line. To say that, we use escape sequence /n. /n means carriage return. You go to the new line. The meaning of that is go to the new line. Those are called escape sequences. So you can write here diff equal to %d, and this second %d value must be d. See here, it will print in the same order. So at the first control string, it will display the s value. In the second control string place, it will display the second variable value. In the third place, it will display the third variable. Wherever there is a control string, there it will substitute the value of that corresponding variable. How many control strings you have, those many number of variables you need to provide here. Okay, so like this you can write it in a single statement also, printf. Okay, so everything is over. Say I've read the values, I have calculated my outputs and displayed my outputs. So I am displayed up to only 3 variables. Okay, you can display all. Okay, so now so declaration is over, reading the input is over, processing is over, displaying the output is over. So my program is over. So the last statement that I need to write is return 0, to say that my program has completed successfully. So now you run this. Let me run this. Okay. So this is my program. So let us run this. So when I run this, your cursor is waiting for what? Your cursor is waiting for what? Because the first statement that we have written here is a scanf. That means it is waiting for reading the value of A and B from the user. So you enter 10 and 5. Say for example, A value is 10, B value is 5. So while giving the input, you remember space. By default, you give a space separator. Okay, the inputs must be separated by a space. So that the delimiter, space is the default delimiter. So that's why only I said while writing a scanf statement, you write a single space or no space. Okay, if you give a single space, that single space will match with this input single space. So it will read till the space, it will read the first value. When it encounters a space, it will take the second value. Or by default, space is the default separator for the input. So whenever you encounter a delimiter space, up to that, this value is considered for first variable, this value is considered for the second variable. Then press enter. So then it will read the first value and store it in A, read the second value, store it in B, and it will calculate all these operations and then it will display now. Sum is equal to, here it has displayed the value of S. Difference, after that /n means it will go to the new line. And here you see that I gave space, so that space came. Okay, if you didn't give any space here, then this diff will also start from first column. Okay, so diff equal to 5. So here in this place, it has displayed the value of D. Second control string place, it has displayed the second variable value. Then slash n. So again, it gone to the new line, and this space, after that I have written product. So whatever you write in double quotes, the same thing it will write it on the screen. If it is a space, it will write space. If it is some text, it will write the text. Wherever you find a control string, in that place, it will display the value of the variable. Okay, so product equal to 50. So it displayed all your output, and once your program is terminated with a successful condition. Okay, so but when you write again, let me run this. So when it run, so it is waiting blank, it is blinking, and that means it is waiting for input. But if you write a program today, if someone is executing your program instead of your place, it will be very difficult for them what input they need to give there. Okay, so that's why what we do is, before every scanf statement, we write a printf statement to say that what input it is expecting. So what input the user has to give there. So if I put a message here, enter any two integer values. Suppose some meaningful information. It can be anything. So printf, inside the printf, I have written, see, enter any two integer values. Okay. Any two integer values. So now if you run the program, what is the mistake?
At the end, after the
Yeah, at the
semicolon.
end you have put. Okay. So run. So now it displayed enter any two integer values, and then it is waiting now. So that you will understand that I need to give two integer values here. Okay. So that's why we use always a printf statement before the scanf. What that printf statement will indicate is, it will give you the message what input it is expecting. That can be any user defined word which will give the meaning to that place, what to your input that you are reading. Okay, so after that you press enter, so that it will calculate the remaining part. Okay, so that is how to read the input and output from the to your program. So in the Thursday session will be taken by Umaya madam. So actually today class is to be taken by Umaya madam, and Thursday class is to be taken by me. But because of some function I have on Thursday, we have interchanged the classes. So today I have covered the week 3 summary. So the Thursday class, madam will cover the PPA session. Programming practice session will be there now. So that session will be dealt by the madam on Thursday 8 to 10 session. Okay. So any doubts?
No, ma'am.
Any doubts, ma?
No, ma'am, all clear.
Madam,
Yeah.
can we have the PDF of your teaching?
Like this PDF is there in your course. The same PDF I have used. In your course notes is there.
Where,
No?
ma'am?
Ma'am, PDF, what
Yeah, I
all you
show
have written?
this Word document I have deleted. No, this notepad I have deleted. No, everywhere.
Yeah,
I have
that
not
is there.
stored.
You have deleted.
Whenever I am discussing, after discussing the concept, I have deleted. No. Okay, that you will find out here. The every concept that I have discussed there, you will find out here. That example might be I given a different example with a different values.
Madam,
Okay.
where
Ma'am,
can we study that?
where we can find the PDF, ma'am?
Ah,
In the course, I'll show you. I'll show you. Wait. In your course only, this is, go to your course, the SIG portal. Okay. Here you will find out
okay.
the materials, supplementary content. So all week-wise summary notes, week-wise summary notes. Okay.
Ah,
If you click here, you will find out the summary notes for all the weeks you can download. So now I have used week 3 summary notes.
okay, ma'am. Okay, ma'am.
Okay,
Have
ma'am.
you
Thank
got
you,
it?
ma'am.
Really, it is a wonderful session, ma'am. I have learned
Yes.
a lot. Yes, I have learned a lot, ma'am. Really wonderful
Yeah,
session.
yeah. Okay. So
Thank
you
you.
go through it. If you have a doubts while going through it, you can even ask in the next sessions.
Okay, ma'am. Thank you.
Thank you, ma'am.
So I am ending the session.
ఇప్పుడు పేరు కొంచెం